2024 A-Level Combined Mathematics Paper 1, Part A, question number 10. This is the trigonometry question. The question says, show that cotangent of theta divided by 1 plus sine theta plus cotangent of theta divided by 1 minus sine theta is equivalent to 4 times cosec of 2 theta. It then says, hence, solve cot theta divided by 1 plus sine theta plus cot theta divided by 1 minus sine theta equal to 8 cosine of 2 theta. Now, to start off with this question, the first thing we're going to do is to copy this thing right here and try to simplify it down into the expression on the right hand side. So we're going to write cot theta divided by 1 plus sine theta plus cot theta divided by 1 minus sine theta. Now, to start off and simplify, the first thing we could do is to try to take everything under a common denominator. And we can see if we want to do that, the common denominator we need is 1 plus sine theta times 1 minus sine theta. And therefore, the first terms top and bottom need to be multiplied by 1 minus sine theta, and the second terms top and bottom need to be multiplied by 1 plus sine theta. So if we do this, we can see we're going to get cot theta times 1 minus sine theta plus cot theta times 1 plus sine theta divided by, and on the denominator we're going to have the product of the two, which is going to be 1 minus sine theta times 1 plus sine theta. Now, considering this, we can see on top, if you simplify, we have cot theta times negative sine theta and cot theta times positive sine theta. So if we add these two together, we're going to cancel them out. Cot theta times minus sine theta and cot theta times plus sine theta cancel out. And if we cancel those out, we're going to be left with cot theta times 1 and cot theta times 1. And therefore, we're going to have 2 cot theta on top. So we can equate this and say this is equal to 2 cotangent of theta divided by, and on the bottom we can see we have 1 minus sine theta times 1 plus sine theta. Now we can see this is of the form a minus b times a plus b, and as we know, a plus b times a minus b is the difference of squares, and therefore this thing right here is 1 minus sine squared theta. So therefore we can write 1 minus sine squared theta. Now here what I'm going to do next is to convert cotangent of theta into cosine theta divided by sine theta, and I'm also going to convert 1 minus sine squared theta into its other form, which is cosine squared theta. We can do this due to the popular identity that cosine squared theta plus sine squared theta for any angle theta is equal to 1. We all know this. So therefore we can write that this is equal to 2 cosine theta divided by sine theta times 1 over 1 minus sine squared theta, which is going to be equal to cosine squared theta no matter the angle theta. Now here we can see on top 1 cosine theta is there, and this can be cancelled for another cosine theta on the bottom, leaving us with 1 cosine theta on the bottom, a sine theta on the bottom, and we have 2 on top. And therefore what we're going to have here is 2 divided by sine theta times cosine theta. Now, in order to get the cosec of 2 theta, what I'm going to do is to also multiply the top and the bottom by 2. So I'm going to take the entire expression here and I'm going to multiply the top and the bottom by 2. So I'm going to get 4 on top divided by 2 sine theta cosine theta. Now, as we know, 2 sine theta cosine theta is equal to sine of 2 theta. This can be found from the identities that we found in previous lessons. So due to this, we know that this is equal to 4 divided by sine of 2 theta. Now 1 over sine of an angle is the cosecant of that angle, and therefore this is equal to 4 times the cosecant of the same angle, which is 2 theta. And we can see therefore we have proven that cot theta divided by 1 plus sine theta plus cot theta divided by 1 minus sine theta is equivalent to 4 cosec 2 theta. So I could take this all and move it to the upper line and write as a summary from this that if we move this to this side, then we have therefore proven that cotangent of theta divided by 1 plus sine theta plus cotangent of theta divided by 1 minus theta, sine theta is equivalent to 4 times the cosecant of 2 theta. Now after this, the next thing we have to do is to hence solve this equation right here. So if we write it down, we can see we have cot theta divided by 1 plus sine theta plus cot theta divided by 1 minus sine theta being equal to 8 cosine of 2 theta. Now here what we can immediately do is to directly substitute the expression that we have here and say that since all of this is equivalent to 4 cosec of 2 theta, we can write directly that therefore 4 cosec 2 theta is equal to 8 cosine of 2 theta. Now we could say this is equation number 1 or something and then say from 1 we get this or something just to make it extra clear, but I think directly substituting like this would be expectable. Now after this we can see if we simplify, we have 4 on this side, 8 on this side. If we cancel the 2 we're going to get 2, and we can also see we have cosine of 2 theta here, and here cosec 2 theta is 1 divided by sine of 2 theta. Therefore, if we take this to the other side, we are going to have sine of 2 theta times cosine of 2 theta. And therefore, if we simplify and cancel out the 4 for the 8, we are going to get 1 being equal to 2 times, this is going to become the sine of 2 theta times this thing which is the cosine of 2 theta. Now here we can see we have 2 times sine of an angle times cosine of an angle, and therefore this can be simplified to the sine of double the internal angle. Now the internal angle here is 2 theta, and therefore this can be simplified to the sine of double of that, which is sine 4 theta, and that is equal to 1 here. And since we want to find the angles theta, we're going to equate this 1 to the sine of an angle that we know. Now as we know, 1 is equal to the sine of pi by 2, and therefore we can see the sine of 4 theta is equal to the sine of pi by 2. Now from what we know from theory, if you have the sine of one angle, let's say A, being equal to another sine of another angle, sine of B, if we have sine of A equal to sine of B, then we can definitely say that A is going to be equal to n pi plus negative 1 to the power of n times B. A is always going to be equal to this, where n is an element of the integers. Now according to this, if we substitute into this given situation, we can see we are going to get 4 theta being equal to n pi plus negative 1 to the power of n times the angle here, which is pi by 2. Now if we divide both sides by 4, we can see we're going to get theta being equal to n pi by 4 plus negative 1 to the power of n times pi by 2 divided by 4, which is pi by 8. So therefore we're going to get this as our solutions, where n is an element of the integers. So here we can see we have an infinite number of solutions for theta, and all of them are of the form n pi divided by 4 plus negative 1 to the power of n times pi by 8, where n is an element of the integers. And with that, we have completed this question by finding all the possible solutions for theta. So now let's finally discuss the marks award for this question. So for this question, when you take everything under a common base like this, and then you go from this expression right here to the expression 2 cos theta divided by 1 minus sine square theta, or 2 cosine theta divided by sine theta times 1 over cosine square theta, for either of these, you're going to get 5 marks. So getting to this point right here, you get 5 marks. Now after this, when you simplify down and you use the identity 2 sine times cosine equal to sine of double the angle, and you write 4 over sine 2 theta as being equal to 4 times the cosec of 2 theta, and get to this point, you get 5 marks for that. Now after this, when you take the expression given, you substitute in your value like this, and you write 4 cosec of 2 theta equal to 8 cosine of 2 theta, you get 5 marks for that. After this, when you simplify, and then from this point, when you realize you have 2 times the sine of an angle times the cosine of an angle, and you write that as double the sine of that angle, or sine of double that angle rather, and you write that sine 4 theta is equal to 1, getting this point right here gets you another 5 marks. And finally, when you say that if sine A is equal to sine B, then A must be equal to n pi plus negative 1 to the power of n times B, and you write this expression simplified down to this expression right here, and write this final line as your final answer, you get another 5 marks for that. And that is going to be all for this question and all for this video. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.